Do you ever wish you could have superpowered vision? The cone-shaped cells in our eyes have evolved over thousands of years to detect what we call visible light. But this light or radiation is just a small part of all the radiation that surrounds us. Sounds kind of scary? Well, without all this radiation, we wouldn't be able to communicate over long distances. We wouldn't be able to land planes in the fog or fix broken bones in our body. And when we look into space, it is only by detecting this invisible light that we get the full picture. Let's see what the universe has to say about this. Welcome to Chasing Starlight. I'm Suzanna Randall, an astronomer at the European Southern Observatory ESO, and I'm so fascinated by light and what it can tell us about the universe that I made a career of it. What we commonly refer to as light is more accurately electromagnetic radiation that can be ordered according to its energy into the so-called electromagnetic spectrum. Waves with longer wavelengths have lower energies, and waves with shorter wavelengths have higher energies. So at the low energy end, we start with radio waves, followed by microwaves, then infrared light, visible light, UV light, X-rays, and finally, we have the gamma rays at the high energy end of the spectrum. This sounds maybe a bit technical, but actually you're surrounded by most of these types of radiation in your everyday life. For example, when sunbathing, you were sunbathing in the UV light of the sun. Or when warming up food, you might have done this with a microwave. Or when listening to the radio, obviously you need radio waves. So we're always surrounded by electromagnetic radiation, a lot of it invisible. With our eyes, we can only see a tiny part of this electromagnetic spectrum. And it's not coincidence that it's this part, the visible light, where the sun also shines strongest. Our eyes evolved to be able to detect sunlight coming off or being reflected off objects in our surroundings. It's also not surprising that the first astronomical telescopes were built to detect this wavelength range. And even to date, many telescopes, including ESOs, continue to observe in the visible. When we look into space in the visible spectrum, we can see stars and galaxies, and also objects that reflect starlight, such as planets or clouds of dust. These images are absolutely stunning, and visible light observations still form the backbone for many areas of astronomy. However, different objects and different processes emit at different energies. So that means that we need to piece together information in different types of light, like a puzzle, in order to get the full picture. In this episode, we'll focus on the lower energy part of the spectrum, because that is the light that we can observe from the surface of the Earth. Higher energy radiation is absorbed by our atmosphere, which is kind of annoying for astronomers, but on the other hand, kind of convenient for humankind as a whole. Without the high energy light absorbing powers of our atmosphere, we would have never left the oceans. Our eyes see the visible light, but our bodies themselves shine in the infrared. And in order to detect this light, we need special detectors that kind of translate the infrared radiation to the visible that we can see with our eyes. In the infrared, we can see things that we cannot see in the visible. For example, that my sunglasses are cool. In space, objects that shine in the infrared are mostly cool stars and planets. For example, the very first image of an exoplanet that we talked about in episode 1, that was taken in infrared light using ESO's Very Large Telescope, the VLT. In the infrared, we can also see things that otherwise are obscured by gas and dust, such as baby stars that are enshrouded by the dust and gas clouds from which they are born. Check out this image of the Milky Way in visible and in infrared light. If we look in the visible, it's a little bit like trying to see the headlamps of a car through thick fog. You don't really see anything. But in the infrared, this veil is lifted as if by magic. Let's travel a little bit further into the low energy part of the spectrum. A lot of this light is blocked out by our atmosphere, but there are parts of this energy range that we can see even from the Earth's surface, especially if we're a little higher up. And that's pretty lucky because otherwise our modern satellite communication and navigation wouldn't work, and I, for one, would be constantly getting lost. One of the biggest telescopes at these energies is ALMA, in which ESO is a partner. ALMA is located on the Chajnantor Plain at 5,000 meters in the north of Chile. And being there is just amazing. It's like being on Mars. Also, in terms of the lack of oxygen. ALMA looks very different to the other ESO telescopes in terms of the design. It looks more like a bunch of satellite dishes, 66 dishes to be precise. And all of these dishes work together to study the cold universe. With ALMA, we can study things that we can't see in the visible or in the infrared. For example, cold, giant molecular hydrogen clouds from which stars are formed. We can also see planets in the making. This means that with ALMA, we can understand the origins of our own star, the Sun, and our own planet, the Earth. Its motto is, "In search of our cosmic origins." If we limit ourselves to what's directly visible, we don't get the full picture. To quote The Little Prince, "The essential is invisible to the eyes." And this applies in life, but also when looking out into space. If we only look in visible light, we only see the tip of the iceberg. Luckily then, really, that as astronomers, or rather our telescopes and instruments, have vision superpowers, and we can use them to detect the light that our eyes cannot see and reveal the hidden universe. If you enjoyed this video, don't forget to hit like and subscribe. And to be notified of future episodes of Chasing Starlight, activate the notification bell. If you have any questions, please put them in the comments below. For every episode, we will answer some of your questions.